Paper 3, quadruple proof, part 4, so this is 15 points. And what it tells us to do is to take A as the origin of a complex plane. So A is the origin if given, assuming A is the origin, which would mean that this right here would be the real axis, and this right here would be the imaginary axis, and this right here would be minus I, and this would be minus 1. This would be minus 2. Of course, it would be over here, right? Minus 1, minus 2, minus 3, and this would be minus I in this line right there. And if that's the case, then E, very simply, can be written as minus I minus 1. F will equal minus I minus 2. Wait, my x's are my I. Got these in the wrong order. First it's x, whichever. Your x is your real axis. So first it's minus 1 minus I. Then f will be minus 2 minus I. They all have the same y value. Then c will be minus 3 minus I. Very good. Now we have to multiply these. Well, I'm going to start by multiplying EF and then multiply by C to make my life a little easier. So EF is going to equal minus 1 times minus 2. That's going to be 2 plus minus 1 times minus I. So it's plus I, right? We're going to FOIL this out. Then minus I times minus 2, which is plus 2I. Then minus I times minus I, which is plus I squared. I squared is minus 1, so 2 minus 1 is 1, plus 2 plus 3I. All right, and therefore EFC is equal to 1 plus 3I times minus 3 minus I, which is equal to 1 times minus 3 is minus 3. 1 times minus I is minus I. 3I times minus 3 is minus 9I. And my 3I times minus I is minus 3I squared. Minus 3I squared is plus 3. Plus minus 3 is 0. We're over here, right? These two terms cancel out, leaving me with minus 10I. Very well. That is the value of EFC. Now, explain why the complex number E can be written as root 2 E minus pi plus AI. Here it's useful to remember that we've already seen that the size of AE right here, which is kind of the magnitude of the vector of that we could describe this number, is root 2. If you're not too sure, we can look at that again. The sine of A is equal to 1 over root 2. Therefore, A is equal to pi over 4. Which means that the rotation of our complex number, which starts at over here, would be of negative 3 pi over 4, because in this axis, A is the origin, and therefore our rotation starts over here, and goes this way, all the way to our imaginary number, and so our angle is 3 pi over 4. Or said differently, it could be negative pi, going this way, plus pi over 4, which is what A is. Now, explain why this can be done. So, R equals root 2, and theta equals minus 3 pi over 4. A equals pi over 4. Therefore, what did we have? We have minus 1 minus I is equal to root 2 E I minus 3 pi over 4 equals root 2 E I minus pi plus A. I think that was fairly clear. I don't think they're going to want more than that for 2 points. Equivalent expressions for F and C. Well, so this is for E, right? For F, we're going to do the exact same thing, but the difference is AF had a different size. I believe this was 1, 2, it's 5, and this was root 10. So F will therefore be root 5. EI, it doesn't actually matter what B is. we'll keep the exact same reasoning as with A, and then we'll do the same thing with C, which is going to equal to root 10 EI minus pi plus C, whatever C is. We know that C plus B equal pi over 2, but more than that doesn't really matter right now. It's only worth 2 points, so if this is not accurate, I will accept partial credit and move on in terms of time management, something I recommend for you as well. Okay, so that was D. No, that was C. Oh, that was C. C, and then this is D right here. Find equivalent. Now, EFC in terms of ABC. Very well. So EFC in terms of ABC, well, if I'm doing this with root 2 EI minus pi plus A times root 5 EI minus pi plus B times root 10 EI minus pi plus C. And you want to remember that when you're multiplying exponential numbers, you add up the exponents, right? These are going to add it up. So just as a quick reminder, e to the x times e to the y equals e to the x plus y. So in this case, however, root 2 times root 5 times root 10, that's equal to root 10 e I. So it's negative I pi plus negative I pi plus negative I pi, so that's times 3, minus IA minus IB, no, plus, this is a plus A, plus IC, which is equal to 10 E minus 3 pi I. Let's plot the I right there. I minus 3 pi plus A plus B plus C. Now, the rotation of minus 3 pi is not... Okay, so hold up. We've got E taken care of right there. We found an alternative expression for EFC in terms of ABC. Out of curiosity, let's just check real quick. EFC... Oh. Well, EFC had 10, and we have 10. So right there, we're talking about the same magnitude. And let's say ABC were indeed equal to pi over 2. But I'm looking ahead to this one right here. It's asking us to prove that. Would that mean that this would be negative 5 pi over 2? Which would be, starting here, negative 2 pi, negative 4 pi, 2 pi over 2, 4 pi over 2, negative 5 pi over 2, which is only an imaginary number, would equal to, okay, that would work. That would be negative 10i. All right, so we have found this. I'm satisfied that we found this in terms of ABC. Now, how do we prove this? How do we prove that ABC equals... Well, maybe just by saying them equal to each other, right? If I set that this is equal to 10EI plus A plus B plus C, then minus I is equal to EI I times B plus C equals E minus 3 pi I times E I C. Very well. E to the minus 3 pi I is, well, if I go here, right, go back to our top right there. So our ratio there is 1, so it's minus 1 pi, minus 2 pi, minus 3 pi, and that's just negative 1. So this was negative 1. So all I need for this is for this to equal to I. This has to equal I. And this is equal to I. Equal I if A plus B plus C equal pi over 2. Oof, this is not the cleanest, but I hope you understand what's going on. Okay, and I think that's acceptable. Well, I hope this helped, and if you have any questions, feel free to